Okay, so this is a second try at section 6.5 over trapezoids. So if you've already watched the first video, then you might want to just jump to the examples, but for those of you who were not able to see the examples, here it is. So I'm going to start at the beginning because it is a whole new video, but let's first define a trapezoid. A trapezoid is actually the only thing that we're going to talk about that is not a parallelogram. That means that opposite sides are not congruent, opposite sides are not parallel, talking about both pairs, diagonals are not bisected, things like that. So definition of a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. So in this diagram, these sides would be parallel, so we mark them with arrows, and they are actually called bases. So this is a base, and this is a base. So then these would be base angles. This is also a base angle, and so are these. Okay. There's not too much that's special about a trapezoid. The only thing that we can talk about really is that the same side interior angles are still going to be supplementary, just like when we had parallel lines cut by a transversal. Essentially, that's the same situation here. So we have same side interior angles supplementary. Okay, so let's talk about an isosceles trapezoid. That is similar to an isosceles triangle in that its legs are going to be congruent. So if we want to go back up to the original diagram here, we know we have two bases, and that means that we also have two legs. So this is a leg, and this is a leg. So in an isosceles trapezoid, it is just a trapezoid with congruent legs. So we can go ahead and mark those. Remember that these are parallel. Something special is that the base angles are congruent. Just like in an isosceles triangle. So these base angles would be congruent, which would make these base angles congruent as well. And don't forget that the same side interior angles are still supplementary. Okay. One other thing that is special about an isosceles trapezoid is that the diagonals are congruent. Now they don't bisect each other, but if you draw them in, they are going to be the same length. Okay. Let's talk about the mid-segment of a trapezoid. The mid-segment of a trapezoid goes right through the middle of a trapezoid. The mid-segment is just a segment that connects the midpoints of the legs of a trapezoid. So, here's the leg, which means I need to put midpoints in there. We know that midpoints are in the middle, so we've got congruent segments here and congruent segments here. Notice that I used one tick here and two ticks here because they're not all four congruent segments, but these two are congruent and these two are congruent. The only time that all four will be congruent is if it is an isosceles trapezoid. Okay, so we've got the midpoints, so if we connect those, this is a mid-segment. So how do you find the length of a mid-segment? Well, mid means middle, or basically the average between the bases. So again, if this is a base, and this is a base, the mid-segment is just equal to the average. So we're going to take half of base 1 plus base 2. And it does not matter which one is base 1 and which one is base 2. You're just summing them and dividing by 2 or multiplying by 1/2. So you're taking the average there. Okay, so let's look at a couple examples. The first one says find the missing angle measures. because these lines are parallel, or segments are parallel, we know that it is a trapezoid since there's only one pair, and we know that the same side interior angles are going to be supplementary. So if we take 180 and we subtract 50, we have 130 degrees remaining for angle P. And then if we look at R and Q, because it is isosceles, we know that the base angles are congruent. So if this is 50, this is also 50. And if angle P is 130, angle Q is also 130. If you checked, all four angles total 360 degrees because it is a quadrilateral, so it does still fit that rule. Okay, example 2 says find DG. So they want us to find the length of DG, which is the mid segment of the trapezoid. So we are going to average the bases. So 8 plus 20 times a half, or divided by 2. So that would make DG equal to 14. Then it says find GH if FH was 15. So in our original information, we did not know that FH is 15, has a length of 15, but now we do. And so it says go ahead and find GH. Well, we know that GH is half of FH because these two pieces are exactly the same. So if we just do 15 divided by 2, we get 7.5. Last example. Find the value of X. This is a trapezoid because we have one pair of parallel sides. And we know it's an isosceles trapezoid because the base angles are congruent. If the base angles are congruent, the legs are congruent, which means their measures are equal. So we can set those two expressions equal to each other. Solve just like you would any other equation. Subtract 4x from both sides, you get 2x. Subtract 3 from both sides, you get 12. And if you divide by 2, you get 6. So x is equal to 6. Now they only said find the value of x, but if they wanted you to find the length of the legs, or if you wanted to check to make sure your answer was right, you could plug x back in and make sure you got the same length for both legs. Okay, so the only thing that you're responsible for here are the checkpoints, and there are only 4 of them. So 1, 2, 4, 5. The numbering is a little off, but that's okay. That is what you're doing.